Welcome children. Now today we will move to a new topic and that is kinematic equation. Before starting kinematic equations, my humble request to you that you please revise the physical quantities if still there is any type of confusion within you. Because we are going to bring the relation between the physical quantities to obtain the relation for our equation of motion. This chapter we have done in class 9, but still we will revise all the things of class 9 and the things of class 11. So we will go for two methods. One is the fundamental graphical method of kinematic equation and second is the finding the kinematic equation by calculus method. So let's we are starting with the graphical method. Graphical method for kinematic equation. In kinematic equation, we have derived the relation between three quantities. One is the velocity, another is the time, and third is the distance. We are finding the relation between two quantities that we have done in the graphs also. So our first equation will be the VT equation. That means the relation between velocity and time. So what was the equation? The equation was V equal to U plus AT. Our second equation was between S and T. S and T, that was known as distance time equation. So it is second equation, that is ST. The equation was S equal to UT plus half AT square. Where we have used to find the distance covered by body when the body is starting with rest or some initial velocity and moving with some uniform acceleration A and time T. Our third equation was the relation between V and S. V and S. So the name of this equation is velocity distance equation V and S. There we have got V square equal to U square plus 2AS. The significance of this equation that we can find the distance covered by a body when starting with some initial velocity or rest with an acceleration A. In this case, we are neglecting the time factor. Let's be not considering time factor. And we started from the morning and now it's 11 a.m. We are not counting that how much time has gone, but if we have started with some initial velocity, then definitely we have come some distance with respect to our starting velocity and starting position. So the first three equation is the velocity time, distance time and velocity distance equation. First of all, we will move for the graphical method. So let's have the graph. We will use the velocity time graph to bring the relation between them. We will move to the VT graph. What is the graph? The graph between velocity and time. This is the velocity, this is the time. We are starting with a non-zero velocity. That means when the body is moving, definitely it is at not zero, because zero is the condition of rest. And we are talking about body is moving, so zero can't be the velocity of a body, because body has some velocity, then only it is moving. So let a body is moving with initial velocity U with an uniform acceleration A. In time interval T, body has attained the final velocity V. Here the body has not stopped, but we are talking that how much body has propagated. So we are considering up to the velocity V. So this one is velocity V. This one is U. So let's write some statement for this also. That let a body start to move with initial velocity U and with uniform acceleration A. Body has gained the velocity or attained the velocity V v at time t second. See the graph, use the initial velocity, use the final velocity, this is the time and this is the acceleration. So what is the acceleration of the body? So acceleration is final velocity minus initial velocity by time, or mathematically we can write a equal to v minus u by t, or v minus u equal to at, or v equal to u plus at. This is the first equation of motion. There we have got the relation between velocity, final velocity, initial velocity, acceleration and time. The significance of this equation, it helps to find the final velocity of the body when the body is starting with some initial velocity and some acceleration in time t. How much body has got the velocity we can find by this equation. Pause the video and write down the things. Okay. Now we will keep the graph as it is for the second equation, and we will keep this statement also as it is for the second equation. Only the things changing, the second equation is distance time equation. That means how much body has covered this distance. That means we look after this space. We look, because body will be somewhere between 0 to b with x component and y component. So our second equation will be st equation, and that also will find by this beauty graph only. So the things will change. These entire statements will keep as it is, will not disturb the statement, but here we'll go for some type of symmetrical position. Now the entire diagram is divided into two geometrical shapes. One is the triangle and another is a rectangle. If this one is u, definitely this one will also u. This is t, then there it will be also t. Now this entire is b and up to here it's a u. Then what will be bd? bd will be, it's v minus u. So distance covered by the body, what is that? It was the area of this two shape. Yeah, because somewhere the body will be within this graph only. So area of rectangle OADC plus area of triangle ABD. Triangle ADB is a right angle triangle. So we'll use the concept of finding the area of this. Now area of rectangle, it is length into breadth. So we'll write u into t. What will be the area of triangle? That is half base into altitude. So base is t and altitude is bd, and bd we have got v minus u. Now what I told at the beginning, that the quantity v minus u, that means here st, so v must not be there. So you have to remove this v, because v is not there on that condition. We have to plot the graph there. So as v minus u, a equal to v minus u at t, so in place of v minus u, we can write v minus u equal to at. Let's see. So we'll, in place of v minus u, we will substitute this value. So s equal to ut plus half t into at. In place of v minus u, we are writing at, or s equal to ut plus half at square. This is our second equation of motion. What is the significance of this equation? The equation helps us to find the distance covered by a body when the body is starting with rest or some initial velocity and moving with certain acceleration for time t. So this is ST equation we are plotting with the help of VT graph. take a screenshot or pause the video and write down the thing. Okay. Now, for the third equation, what was the equation? It is the relation between velocity and distance. So, in place of this, we will write velocity distance equation. Again, we will keep entire statement as it is. We will not disturb the statement because that statement will be carried forward to the next equation. Now, in this case, which quantity is absent? That means which quantity we have to ignore. We have to ignore the t. T is not there. So we ignore that quantity. So what we are doing? We are removing this t. When we are removing this t, then again this entire becomes v. It is v. Now, just look, the shape. The shape is OABC. Which type of shape this is? Yes, it's a trapezium. So this case, the area or distance covered by the body will be given by the area of this trapezium, OABC. So what you will write? So distance covered by the body will be S equal to area of trapezium OABC. So S, what is the area of trapezium? That is half into sum of parallel side into separation between them or perpendicular distance between them. So parallel side what? OA and BC. In place of OA we will write U, in place of BC we may write V, and in place of this OC we have to write time. Again, time must not be responded because it's the equation between V and S. So you have to remove the time. How to remove the time? Again from the acceleration. So A equal to V minus U by T, T equal to V minus U by A. You can write. So in place of T, we will substitute this value here. So S equal to half, it's V plus U, we may write, and V minus U by A. So it's V plus U, V minus U by A. So what we have, it's the half V square minus U square by 2A. Or we may write 2AS equal to V square minus U square. This is our third equation. What is the significance of third equation? It helps to find the relation between velocity and distance of the body when the body is starting with some initial velocity and moving with some acceleration and achieving some final velocity. Please pause the video, write down the things or take a screenshot. Okay. Now, these three are the equation of motion when the body is moving for definite time interval. That means when we are talking for 2 seconds, 3 seconds or 5 seconds, that means a fixed interval of time we are giving. Then these three equations are there. But if you have to find that what or how much distance body has covered in a definite time, in a particular time, that means if the body has covered 4 seconds or body has moved for 4 seconds, how much distance body has covered in third second or second second or on the fourth second, then these three words and these words are not same. Because here 4 seconds means entire 4 seconds, 1, 2, 3, 4 all. But here means second means on that second how much body has covered. 4 seconds means out of 1, 2, 3, 4 how much the body has covered on that 4th second, not entire 4 seconds. So we have one more equation for that, and that is known as fourth equation of motion. Fourth equation of motion. Fourth equation of motion, and that is the distance covered in nth second. Nth second. For that, what we are taking? We are taking the entire time equal to n. Now, when we will subtract n minus 1th term, then we will get the nth term. Let's see this. If time of journey is n second, so distance time equation will be distance time equation will be s equal to un, in place of t we are writing n, un plus half a n square. First equation. Now distance covered in n minus 1 time, distance covered in n minus 1 second. What will be n minus 1? That is, if we are talking about 10 second, then 10 minus 1, 9 second. Now 10 second minus 9 second will go out for the last 1 second. Please think. Total distance covered by your body is for 10 seconds we are talking. And if you find for distance covered in 9 seconds, now total time, that is 10 seconds minus 9 seconds, that means we'll get how much body is covered on the 10 second. Yes. So distance covered in n minus 1 second will be s equal to u n minus 1 plus half a n minus 1 whole square. Right? So to find distance covered in nth second, that is s nth, please see here, s nth, not n, will be sn minus s minus 1. We do so? Yeah. So please simplify this. S nth, what is Sn? It is un plus half an square minus this we are simplifying. So we are directly doing the simplification. U into n, un minus u plus here half a minus b whole square. So we'll explain it. It's the a square plus b square minus 2ab. Right? So now Snth will be un plus half an square minus un minus u plus, here we are simplifying, it's the half an square plus half a minus half a into 2n. Am I right? So just we are simplifying that, you can do by yourself also. So it's the un plus half an square. Now we're taking out the things from the bracket. So outside there is minus, so all the sign will change. So what we have minus un plus u minus half an square minus half a plus 2 to cancel, it's an. Now please see the terms. un, half an plus half an minus, this cancel. So what is the term left? It's a u half an plus an, this much only. So after simplifying, what you will get, s nth equal to u plus an minus half a. That is the term left here. So this is the distance covered by the body in n second. What are the terms? We are going for s for n time. So it will be un plus half an whole square. Second statement, we are going for n minus 1 term. So it's a un minus 1 plus half an minus 1 whole square. Now from the total we are substituting the second last. So we'll get the last term. So Snth will be Sn minus Sn minus 1. In place of Sn, what we have written, un plus half an. Sn minus 1 is un minus u plus half an n square plus 1 minus 2n. Just we have extended that into a minus b whole square. After that we have moved to un plus half n square minus un plus u plus half n square plus half a into 2n, that is an term. Now we are taking out the terms. So un half an square, un plus u minus an square minus half a plus an square. After simplifying, we will got this term. So this is the fourth equation of motion. There we have calculated the distance covered by body in n second. It will be used when we are talking for the instantaneous time of that individual period, that how much body has covered in 4 seconds, how much distance body has covered on the last second. So please write down all the terms in your copy and do practice. I have already given some numericals. You try your best to sort it out. If still you are facing any doubt in any problem, then feel free to WhatsApp me on my personal number. Thank you.